That's nice. Remember the girl in our friend class? Oh, it said it's an ion. It's an ion minus. There. I'll also look it over. Because it said later, it said the next question just said ions. If it's in negative.
Okay, I sent out a remind text yesterday. The quiz is going to be on Friday. Okay, quiz is on Friday. We're going to go through our couple of quiz reviews today and tomorrow. For the quiz, I will give you the identity. Okay. But for the test, you're going to have to memorize it. Okay. As for the quiz, I'll give this to you at the top. Okay. So your quiz is going to be 5 problems with a bonus. You can choose to do the bonus or choose not to do the bonus. But with the 5 problems, you can work through all 5, but you're going to omit one, okay? Because I'm not going to grade one of them. So you decide which one that you're going to remove. Work through all 5 and see which one that you don't feel as confident in. And you can remove. I'll give you, you get to use your calculators, but it's not a whole lot to use the calculator.
Or just like do all of them, and then you just take out the one that we got wrong.
Like you gotta decide which one you want to remove. Because I'm gonna skip over the one that you remove. Yeah, you decide which one to remove. And you should know whether you're on the right track or not, right? Because we're just verifying, right? If you can make your way from the left side to the right side, you should be confident that you have to that you're able to get full credit for that problem. Right? You know where to start, you know where to end, so I can fill in the gap in between. Okay, let me go through a couple of trig identity strategies here. I'm not gonna leave this on the board for Friday, but I just wanna keep this up until tomorrow. So, but there's not gonna be a specific order that you do these things, right? You're always looking at the right side to see, okay, am I able to do something that will get me closer to the right side? And these are a couple of strategies. One is rewrite as sine and cosine, right? Sometimes that can kind of help jumpstart our process of moving towards the right side. Look for trig identities. So we have these trig identities. Anytime I see a sine squared, tangent squared, or cotangent squared, I'm always thinking, oh, is there something that I can quickly use to get me closer to my result? Combining fractions. Sometimes if I see a bunch of fractions and I see there's only one term on the right side, that gives me an indication that maybe I need to merge all these fractions together, get it under one fraction, and then I can kind of clean up individually. Factoring can also lead me to potentially getting me closer. Maybe factoring out a GCF, maybe doing difference of squares, maybe trinomial factoring. Okay. Sometimes we're trying to split up into multiple terms. Maybe you start off with one fraction on the left side, and the right side has multiple fractions. You can always split a fraction up this way, right? So if I have a plus b over c, I can split up into a over c plus b over c, right? I can take that denominator and I can split it across 2 fractions. And finally, if I see a bunch of parentheses, maybe I want to expand my parentheses out so I can merge and combine and work towards the right side. Okay, so let's try number 1. Sine times cotangent times secant equals 1. What do you think is maybe an obvious step that we can take? Yeah, I think that's right. Everything turns sine and cosine. We're hoping things will cancel out and we can get that 1 to show up. Okay, so try that. Okay, I gave you guys the key as well, but hopefully you can try each problem as much as you can before you look at the key, right? So you can kind of just kind of Okay, does that come out to be 1? Yes, right. Sine goes away, cosine goes away. Okay, take a look at number 2. Again, there are potentially multiple ways that you can get to the answer, but I'm going to choose the one that I find is the most efficient. But if you're going down a different path and still arriving at the right side, that's perfectly fine. Okay, you don't have to. You just have to justify each statement with an appropriate step. What's something that you guys see with number 2? Eventually, yes. But is there something that we can do first before? Yeah. Yeah, we could do that.
To change cosecant or cotangent.
Okay. That's what I'm thinking. I think GCF is a little cleaner. We can do all these things that you guys mentioned, converting to be sine and cosine fractions, but if I see a GCF, I think that will kind of help me move a little faster, right? You see how there's 2 terms here and they both share cosecant squared? If I factor a cosecant squared out, and when I factor, I divide it out, okay? So don't think in terms of that you're subtracting anything away. You're actually dividing that GCF away from both of those terms. And that can kind of help you see what's left over, okay? Whatever is left over will go inside the parentheses. What's cosecant squared divided by cosecant squared? What's this fraction divided by this fraction? Yeah, 1, but then there's leftover cosine squared, yeah. And so we can, I think it's a lot faster, right? So now, what do you see that we can take care of? Yeah, trig identity. 1 minus cosine squared, I can turn into sine squared. Okay, what's nice about cosecant squared and sine squared? They're reciprocals. So if I want to convince myself here, I can say, well, I know cosecant squared is 1 over sine squared. Does that clean out to be 1? Okay, number 3. I'll just start that one. Yeah, looks like number 1, right? Hopefully everything will just cancel out like before. All right, everybody okay? 1 through 3. Okay, number 4. Is there a obvious first step that we can try to do? Yeah, let's just get all the parentheses to go away. And we're hoping terms will combine in a way that we can move forward. So we're going to end up with 4 terms, and then we can see how that cleans up. Okay. What do you guys see?
Middle two cancel.
Good. Middle 2 goes away, right? Sine, cosine, the same thing as cosine, sine. All right, so I know that both of these individually can be replaced with trig identities, but I'm looking at my right side saying, okay, I only have cosine, so kind of makes sense if I just change the sine squared in the hopes that I can get that to be in terms of cosine. I can leave this cosine alone because I'm already sitting at cosine. Okay, trig identity. I know sine squared plus cosine squared equals 1, so sine squared equals 1 minus cosine squared. What's negative cosine squared minus cosine squared? Negative 2, right? There's 2 of them, right? Take a look at 5. What would you do as your first step?
He knows, cancel out like that, one minus cosine.
Yeah, we could, but I think this is here to help us out, right? If we're back to this, it's not gonna, I think that 1 minus cosine is to help you out. What can we do? Cross, we're not working on both sides of the equation, so we're never gonna cross multiply. Let's just multiply across, right? Don't change from there. Let's multiply across. Remember, we're only working on the left side. We're not gonna involve the right side, right? The right side is our goal. So I'm just gonna multiply these together. Really, I'm just putting it under one fraction. Okay. Did I distribute the numerator? I'm gonna leave the numerator alone because I see the 1 minus cosine that I want to reach. If I distribute that sign through, it kind of muddies it up a little bit. So I'm gonna leave the numerator alone. But the denominator, if I fold this out, maybe that will turn into something that is useful. All right, so I'm gonna leave the numerator alone because the 1 minus cosine is already showing up in the end. Okay, so FOIL this out. how does the denominator clean up here? Your cosine cancels. All right, let's see what we have left. And keep looking back at your end goal. Are we any closer? Yeah. So I don't want to be factoring this because if I factor, I'm back to where I came from. But if I use an identity, I get this in terms of sign. If I get it in terms of sign, then I can take one of the sign away from the numerator, and that should lead me to where I want to get, where I want to be. So there's an identity I can take here. So I have one sign above, two sign below. I can remove one from both the top and bottom. The numerator has the sign removed, but there's still one left over in the denominator. I want to keep reminding you that sine squared is really just sine and sine. You don't have to go this far, but I want to make sure that we understand that that's what that means. There's two signs here, and you can, if you can understand that there's two of them, we can remove one. We still have one left over. Okay. Okay, number 6. Any suggestions here? Good. In terms of cosine and sine, yeah. So that's one way. We'll go through that way. I want to show you a different way. Just kind of give you options. I think they're both good, but I think the more options you have available, then if one doesn't work, you can always try another one, right? So let's try the method where we get everything in terms of in this case cosine. Makes it a little bit easier to merge. Okay, it's going to force some fractions to show up, which means I have to do what? All right. Ideally, I want to merge these together, but if I want to merge these together, I got to use common denominator, right? So let's worry about the top first. What's the common denominator for my upper two fractions? Cosine theta. That's large enough for both these denominators to go into. Okay, let's balance fractions here. Any adjustments needed with the first fraction? No, so bring the 1 over. Any adjustment needed here? I need to multiply the top by what? Cosine. Yeah. Now that I can merge it into one fraction, so now I can try to get the two fractions to combine together because now that the numerator is a little bit cleaner, I can multiply by the reciprocal, but I wanted to take care of this first before I move that denominator up. But now that denominator can come up, Okay, everybody okay so far? If something doesn't make sense, ask that question so we can make sure that you're back on track. But everybody okay so far? Right. What's nice here? Cancel. So I'm just left with 1 minus cosine squared. Am I any closer to my right side? Trig identity, yeah. Okay, I have some space below. I want to show you a different way of working through this, just to kind of show you. Any thoughts as to if there's something else that we can do that would give us a different approach? Yeah, so what if we split into individual fractions? Maybe that can give us some identities to play with. So I'm going to split up into individual fractions. I can say secant over secant minus cosine over secant. Now on the quiz, you only show one way. You don't have to go through multiple ways, but I just want to kind of show you. All right, what's secant over secant? It's 1. And I can clean this up, right? I can multiply by the reciprocal. What's the reciprocal of secant? Cosine. And then cosine times cosine is cosine squared. And what's 1 minus cosine squared? That's squared. Okay, it's a little faster, but I know that we've been practicing with this a lot, so this feels more natural, but it's just nice to potentially see a different way of working through a problem. As for 7 and 8, sorry about the second row here. I was making a copy and I didn't delete it, so I'm going to remove that. So maybe what we just did with 6 can help you with 7. Separate. Okay, so I'm looking at this thing. I think the separation is going to move me closer to my answer because I have one fraction on the left, but I have 2 terms on the right. So if I split up, maybe I can get those 2 terms to show up. One over secant squared is the same thing as this cosine squared. And secant squared over secant squared is 1. So I think we reached the end. All right, number 8. What do you think we could do as your first step? Common denominator, right? Common denominator first, and then we can worry about the rest later. All right, what's our common denominator? I need both, right? I need 1 minus cosine and 1 plus cosine.
which does end up being 1 minus cosine squared, but I just want to make sure we can see everything separately. All right, we got to do the job of balancing each fraction. Are the denominators the same? We got to figure out what's missing. What's different between the old and the new? 1 plus cosine. So I need to balance the numerator with the 1 plus cosine. What's different here? Okay, we can merge all this together, add the numerators, and then copy the denominator since it's the same. All right, what's next? Yeah, that denominator, I probably want to, there's no parentheses, right? It's just one term, so let's fold that out. And what about the top? What does that give us if I clean up the numerator? Just 2, right? Cosines goes away, and I add the ones together. Okay, I'll go ahead and FOIL my denominator as well. Middle term goes away. What is 1 minus cosine squared? Sine squared. Am I any closer to my end result? Yeah. Reciprocal of sine is cosecant. Bring that up, and we have our goal. All right, worksheet 2. All right, what do you see with number 1? Anything stand out? Yeah, that denominator, I can do a quick replacement. All right, with an identity, secant squared minus 1, the same thing as tangent squared. We're okay with that step. Okay, what's next? Sine and cosine, right? It kind of gives us a quick way of combining what can be combined. Even though sine and cosine doesn't show up on the right side, it's a easy way of seeing what is similar. I have a fraction divided by a fraction, so I just do a fraction multiplied by the reciprocal, right? Okay, what goes away? Okay, are we near the end? Is 1 over sine squared same thing as cosecant squared? Yes. Okay, number 2. Oh, start.
With denominators.
Yeah. I have 2 separate fractions. I have only 1 term here. Let's try to find a way to merge them. But to merge them, I need to find
Oh, no.
common denominator. What's my common denominator?
Sine plus cosine. Sine plus cosine.
Yeah, so let's not do too much, okay? You may feel like you want to distribute, but leave your denominator separate. That way you can see the individual parts and then you can see what needs to be balanced. So if you see 2 separate fractions, keep those 2 separate fractions. Don't try to merge them just yet.
Keep the 1.
Yeah, we have to, right? Because that 1 doesn't just go away. It's part of the fact that it's plus. We can't just make it disappear. Okay, so now if it was 1 times cosine x, then yeah, we can just make it disappear. But the fact that it's 1 plus makes it a completely different thing, and you can't just lose it. Okay, balancing. What do we need to do with the first fraction? Good. We need to multiply top by 1 plus cosine. So eventually I got to FOIL this out. All right, second fraction. What's different? Sine. So I need to multiply the top by sine. Okay, I'll go ahead and make it sine squared. Now that I have common denominators, I can make it all 1 fraction. As I do that, I'm going to just go ahead and try to FOIL this out along the way. Okay. I will leave the denominator alone. I think that 1 plus cosine x is going to be maybe helpful down the road, so we don't want to lose the separate pieces, but the numerator, we can definitely do some work there. Yep, okay, good. 1 plus 2 cosine x, we'll definitely do that. Anything else that you see? Good. All right, I see a trig identity that I can take care of. Is there other like terms that can go with that? Yeah, cosine and cosine, and 1 plus 1 is 2. So I have 2 plus 2 cosine of x. Okay, getting closer.
there anything that I can do to make my numerator look more like my denominator?
Because you can,
Yeah, I don't want to distribute that denominator. That 1 plus cosine x is gonna be useful for us. How about the numerator?
factor it out.
Factor, yeah. Now, we can only do that difference of squares if it's like 4 minus cosine squared, right? But here, this is a DCF problem, right? There's a common factor of 2. So if I factor 2 out, that means I'm dividing both terms by 2, right? 2 divided by 2 is 1. 2 cosine x divided by 2 is 1 cosine x. And if you're uncertain about your factoring, you can always confirm it by redistributing. If I can redistribute and get back to where I started, I know I did my factoring correctly.
Wait, I understand that 2 plus cosine x, but why did 1?
Because cosine squared plus sine squared is what? It's 1. And there's another 1 right here, so I just merged the 2 ones, made it 2. Okay, what goes away here? Okay. And 2 over sine x is the same thing as 2 cosecant x, right? Bring that sign up, flip it, make it cosecant. Okay, number 3. Let's see if we can finish 3 and 4. Let's
Distribute.
distribute. We could, but do you see something that we can
Trig.
use? Yeah, yeah, do these fall under trig identities, right? Because maybe folding is good, but then whenever I see a square trig, I'm always thinking, okay, is there something that I can do involving my identities here? So cotangent squared plus 1, can I play with this to get something that's equal to what? What's sine squared minus 1? Wait, careful. Sine squared minus 1 is equal to negative cosine, right? If I want to bring that 1 over and make it sine squared minus 1, that cosine squared is going to go to the other side. It'll be a negative. Okay. All right, what's next? Yep. Let's put it all under one fraction. What's cosine over sine? Okay, number 4. Does the numerator remind you of what we did yesterday? We got to go through it. Trinomial factoring. So let's create an easier version of that numerator. Let's do x squared minus 2x plus 1, right? Let's factor that. It feels
a little bit less daunting without all the signs in the way. And then once we factor it, we can bring in the sign. So we ask ourselves what multiplies to be 1 and adds it to be -2. -1 and -1, right? Okay. So -1 and -1. You can either go through a star method, or if you like grouping method, I can show that method as well. So I'm just basically taking that -2x and splitting them into -1 and -1. And then do the GCF for both pairs. GCF for the first pair is x. The GCF for the second pair is a -1. Your two sets of parentheses should match. And then the leftover will get their own parentheses. So there's my factor form, x -1, x -1. We started off with sign though, so let's bring sign back into the problem. So that's the factor form. That's what goes in the numerator. My denominator is just sine theta -1. Okay, VC. Cancel, cancel. I have my result. Okay, we'll finish worksheet 2 tomorrow and do worksheet 3. Okay, I'll have a help session to fifth period today. Tomorrow early, I have a meeting at 7:45. So if you want to come in 7:15 to 7:45, work through some problems, or fifth period. Okay, tomorrow. Okay. So how do you take factor? Do you factor the star method, or do you factor the grouping method? So you ask yourself, what multiplies to be -1, you ask to be -2.
Sorry, I'm sorry. I don't know.
1 by 2 is -2, that's going to be -1. So it means So I got to yeah, it's
Who was it? He was messing with you. Dude, I literally, when you started.
So that's the same thing as that, right? I still didn't the way that it's
And you
helpful.
said, oh, I love it, that's. And I went on my future to guess. And you'd be like,
Okay, so that's what time.
PCF of x squared
I literally,
minus
sound like,
I have x minus.
Is this big?
And here, PCF.
Take out that, that's what I'm like.
So if I take out a -1, if I divide by -1, I get x minus.
And then you just.
Yeah, and then if I have, my parentheses are matching, I know I'm in good shape. This was good. So this gets its own set of parentheses, I can share. And then bring back the variable that you're working with.
Sign. Okay, so then you just basically write sign in front of the.
Yeah, I'll replace the x with this. Yeah,
Absolutely not, I'm never sharing out.
they're gonna get their own.
I'm modified.
And then the share only shows up once.
Is there any way to touch it? I didn't realize that negative.
Yeah.
But I forgot to take the big.
Yeah, I would work through the rest of the worksheet.
Well,
If you have any questions, you can ask me.
I just, I should have been.
So you took.
I got married after Miss Nursing.
Oh, so you took out your eighth grade.
Yeah.
But it's young.
I was in. Just.
Oh, did you not take algebra?
I took it out with two lives.
Big geometry.
Definitely.
I'm saying I took algebra 1. Eighth grade, that's what I was saying. Yeah, I didn't do that. I didn't know what I did.
I should have.
Of course.
Eighth grade was